Comment 1552 tells you that you have to be very careful when squaring both sides. The whole point of red dudes is that they're supposed to produce lines that are completely equivalent to each other. So if I take away 2x on both sides there, I get x equals 1. The idea is that these two lines are supposed to say exactly the same thing. This one says it concisely, this one says it not very concisely. Another example here, 2x plus 1 equals 7, 2x equals 6, x equals 3. They all say exactly the same thing. If this is the case, then this is the case. If this is the case, then this is the case. If this is the case, then this is the case. They're all just different versions of the same thing. Now, squaring is not like that. When you square both sides, you can rescue something false and make it true. So negative 2 clearly doesn't equal 2, but if you square both sides, you get something true. So therefore, squaring is not like a regular red dude. These two lines are clearly not equivalent because that is false and this is true. Now, what does this mean for you in practice? It means that you should be very careful about squaring both sides in order to get the solution to something. So by all means do it. X squared equals x plus 2. Then solve the equation. But for goodness sake, go and check that these two things make the original equation true. If you put a 5 in there, you get the square root of 25, which is 5. If you put a 5 there, you get the square root of 25, which is 5, so it's sweet. If you put a negative 4 in there, you get the square root of 16, which is 4. If you put a negative 4 in there, you get the square root of 16, which is 4. So those two answers are both sweet. But what I'm telling you is that there are examples where when you substitute these back in, you do not get the same thing. So for example, on the left you get square root of 9, but on the right you get square root of negative 5, which are clearly not equal. So the rule of thumb is, by all means, use the squaring both sides red dudes, but for goodness sake, substitute your answers back into the original equation to check that it's true. The reason why you have to do it is because in your very first line of working, you create something that is useful for solving the original equation, but which is not perfectly equivalent to it.